Okay, so let's take a look. We're sort of expecting one of these to be an installment loan and the other one to be continuous compounding. But if we want the most learning from this, we'll just kind of wipe that from our head and try to figure out all the clues that are going to tell us which formula to use for each one. So number 5, Ed decides to buy a new car and takes out a loan. Right there, that's a key word for me, loan. So I know if he's taking out a loan, it's probably going to be an installment loan. So let's see if we have any more clues. He negotiated a sales price of $21,500 after his trade-in was considered. The dealership is offering 3.2% interest on all 5-year new car loans. What will his monthly payments be? Well, there's another clue right there, monthly payments. So his payments, he's going to be making payments and he's buying something and taking out a loan. So all those together are telling me installment loan. I'm hoping you're seeing those same clues for yourself. So part A, we want to know what his monthly payment will be. I need to use the installment loan formula. And I nearly have that one memorized, but not quite. And it is P equals F times little q times the quantity q to the big T minus 1 all over q minus 1. Okay, and remember q is going to be 1 over 1 plus little p. Little p is r over n. And then our capital T, maybe I'll put this off to the side just a tad. Our capital T is the number of payments that he will make, Ed will make, and it is also calculated by n times t if you have that information. So what will his monthly payment be? Remember the this P here is the monthly payment, so that's what we'll be solving for. So the F is the, nope, I take it back. This P out here is the total loan price that he's taking, the $21,500, so we'll put that down here. And then the F is going to be the payment amount. Q will, let's figure these things out. So the little t is 5 years times, if it's a monthly payment, then it's going to be 12 for the N. So 12 times 5, he'll be making 60 payments. And then the periodic rate, the little p, is going to be his interest rate. So it's 0.032 for 3.2% divided by that 12. And then we can calculate the Q at the same time. So try this calculator, I guess. So I have 0.032 divided by 12. And there we get that value, 0.00266. And the 6 is a repeating. And then I want to add 1. So plus 1, and then do the inverse to get the Q equals. And so my Q is going to be 0.9973. And I can see I'm using it in 3 different places in my formula, so there's no question in my mind. I want to store that somewhere, and on this calculator I will be storing it in A. So I'll put that next, and then the F I need to, when I'm working here, it'll be multiplied by A, and I'll circle that, and then A again to the capital T, which is going to be 60 minus 1, and then again the A minus 1. So we're ready to go to the calculator again. I do need to store this. I haven't done that yet. Store it in A, and that's the default, so it'll go right in if I do equals. And then get my pointer on here. First thing I want to do is raise the A to the 60th power. So to the, it's right there, and then 60 equals, and you can see I have 0.8523, and then I need to subtract 1 equals, and now you can see I got a negative value, negative 0.1476, and on. And I want to store that, so we'll do store, and I'll put it into B because I don't want to lose that Q, which I have stored in A. That's my numerator, so I'm just going to make a little note here that I put this into B for that whole numerator. And then I can go ahead and do my denominator, so I'm going to have to get back my Q, which I had stored in the A bin, so I just do second store to get recall, and then the A bin. And there's my Q, and then I need to get my pointer back here. Right there, subtract the 1, so minus 1, and that's my denominator. Now remember, if I want to multiply by this numerator, I just have to use this inverse button here. So inverse equals times, and then I have to recall and get that B, so recall B, so move over to the B and push enter. We've pretty much got this whole thing done. We just have to push enter one more time. And I have 55 point something, so I'll write that 55.525, and it does go on. And I'm going to multiply that by A one more time, which is what's stored in A, so times recall A, enter, and now I have 55.378, and I want to do the inverse of that because at this point I've calculated all of this part on the right hand side, and now I need to basically take the 21,500 divided by all of this. So I could store it and divide by it, or I could use my inverse button and multiply. So I'm going to use my inverse button now, inverse, and then times the 21,500 equals. And so my F, which remember stands for the payment, is going to be $388.24. So $388.24. And that's his monthly payment. And then part B, I need to find out how much interest he's going to pay over the life of his loan. So I'll take his payment amount, $388.24, and I will multiply by how many payments he's made, which is the capital T. When he's done, he'll have made 60 payments. So I'll type that in, 388.24 times 60, and I get the total that he will pay over the life of the loan is $23294.40, and that's interest plus principal. And then the way I can find out how much interest he pays is by subtracting off the $21,500 that was the cost of the car that he financed. So minus $21,500 equals, and I get the amount of interest on this car, so $1,794.40. So that's the amount he will pay in interest. The $388.24 is the amount he will pay each month.